Solving a right triangle means that we would like to find the measures of all of the angles and all of the sides of a given triangle. We'll start out by drawing a picture of our triangle. So we're asked to solve the right triangle ABC if B equals 28 degrees and 40 minutes and A is 25.3 centimeters. Let's start by drawing our triangle. It's a right triangle, and traditionally C represents our right angle, and we'll call the other angles capital A and capital B. And we know that B is 28 degrees and 40 minutes. Go ahead and label that. And we are given that side A is 25.3 centimeters. This would be side A, so we'll call that 25.3 centimeters. And side B would be across from angle B, and side C is across from angle C. So we are asked to find angle A. We need to find sides B and sides C. Now, finding the angle A is easy. 90-degree angle is our angle C, that's our right angle. B, we already know that, and we know that when we add up our angles, A plus 90 degrees plus angle B, 28 degrees and 40 minutes, that the total has to be 180 degrees. So let's solve that for angle A. So 90 plus 28 degrees and 40 minutes. Let's see, that would be 118 degrees and 40 minutes. And then subtract 118 degrees 40 minutes from both sides. Oops. So A equals, and we'll have to borrow, so we'll call this 179 degrees and 60 minutes. And that leaves us with 20 minutes and 61 degrees. So 61 degrees and 20 minutes would be the measure of angle A. Now what about sides B and sides C? Well, in order for us to use the Pythagorean theorem, we have to know two sides, but we only know the length of one. So here we're going to have to solve what we call a trig equation. So working from the angle that we know, that we were given, working from the perspective of angle B, let's form a trig equation based upon one of our trig definitions that involves A, the side we know, so we want to involve side A, and let's say side B, one of the sides that we don't know. It doesn't matter if you were working with side C or side B, but we want to set up a trig equation that has only one unknown. So if I'm working with angle B, and I want to work with sides A and B, well, side B would be opposite, side A would be adjacent. So opposite and adjacent, that sounds like tangent. So tangent of angle B would be equal to opposite over adjacent. We're going to set up our trig equation. We know angle B is 28 degrees 40 minutes. We know that equals to opposite over adjacent, so side B, well, I don't know side B, but I do know side A, 25.3. So we have a trig equation with only one unknown. Now we can solve for that one unknown. We can solve for angle B, or side B. So we're going to solve, get B by itself. I'm going to multiply both sides by 25.3. That way it cancels out here, and I'm left with B is equal to, and we're going to type this into our calculator, 25.3 times tangent 28 plus 40 divided by 60, just like we talked about in section 2.3. and I get 13.832222071. We're going to round to the nearest tenth, because that's what the other side is rounded to. So the nearest one decimal place, our side B then would be 13.8 centimeters. So we can solve for side B using a trig equation that involves only one unknown. Now once we have done that, once we have solved for side B, (13.8 centimeters), now we can solve for side C. Now solving for side C will be a little bit easier because we already know two sides, and we can use our Pythagorean theorem now. A squared plus B squared is equal to C squared. Okay, we can just put this into our calculator exactly as we have it. 25.3 squared plus 13.8 squared. Set enter. We get 830.53 is equal to C squared, and now we need to take the square root of both sides, and all we have to do is put that into our calculator. And I get 28.8189, etc. And we're going to once again solve to the nearest tenth, which makes our answer for C to be 28.8 centimeters. Example 2, we want to solve the right triangle ABC if side A is equal to 18.9 centimeters and side C is equal to 46.3 centimeters. Let's start by drawing a right triangle, and we're going to label this as angle C. Let's call that angle A, angle B, and then our sides A, B, and C. So we're told that side A is 18.9 centimeters, so we'll go ahead and label that, and side C is 46.3 centimeters. Now this time it's going to be easy to determine our side B. So let's see what we're looking for. We're looking for side B, we're looking for angle A, and also for angle B. Those are the three unknowns. So this time it will be easy to solve for the third side because we already know two of the sides. We're solving A squared plus B squared is equal to C squared. So we know that A is 18.9 squared plus B squared, we don't know that one, is equal to 46.3 squared. So we're going to subtract from both sides 18.9 squared. So we know that B squared is equal to 46.3 squared minus 18.9 squared. We're going to put that into our calculator as we have it. 46.3 squared minus 18.9 squared. And we get that B squared is equal to 1786.48, and we are going to take the square root of both sides. Once again, we'll just let our calculator take care of that. And we get that B is equal to 42.2667. We're going to round to the nearest tenth again. So that means that the 6 will put B to be 42.3 centimeters. So we know two of the sides. We could find the third one very easily using our Pythagorean theorem. Now we are looking for angles A and angle B. We already know that angle C is 90 degrees, so we need to find the other two angles. Okay, let's find angle A. And we're going to find angle A using the sides that we were given at the beginning. So for angle A, the sides we knew would be the opposite side and the hypotenuse. And opposite and hypotenuse deal with sine. So we're going to set up a trig equation based upon the angle that we want to find and two sides that we already know, A and C. So sine of angle A is equal to 18.9 divided by 46.3. And we're going to put this into our calculator. We're going to use the inverse function. This time we want to find the angle, and the inverse function is what we use to find angles. We're going to put this into our calculator. We're going to hit the second button or shift. In your calculator you should see sine with a -1 at the top, and then in the parentheses we're going to put 18.9 divided by 46.3. And we get that angle A is 24.09227. We're going to round here. Let's round to the nearest 2 decimal places. So that gives us 24.09 degrees. Now that we know two of our angles, to find the third one, it's going to be very easy. We have 180 degrees to begin with. We can subtract off 90 degrees for our angle C. That leaves us with 90 degrees left over. And now we can subtract from that angle A 24 degrees and 24.09 degrees. And we just put that into our calculator, and our calculator gives us 65.91 degrees for angle B. So once we know two of anything, the third one is always very easy to find. Now for example 3, we're asked to solve the right triangle, and this time we're actually provided with a picture. We know angle B and angle C, and we know side B. What we're looking for now is what is the measure of angle A, what is the measure of side A, and what is the measure of side C. So these are the three things that we are going to try to find. And let's first find angle A. Since we know two angles, the third angle is very easy to find. So you can say 180 degrees, take away 90, that's for our angle C, we're left with 90. And now we can subtract off from that 45 degrees and a little bit more there. We're just going to let our calculator do that work for us. And I get 44.9107 degrees. So our angle A, and we'll just leave it rounded to the nearest 4 decimal places since that's what B is rounded to. So there's my angle A. So anytime I know two of something, the third one is very easy to find. So now I'm looking for sides A and side C. Okay, we're going to start with the angle B that we know, and we're going to involve the side B that we know. So we have two things that we know, and we're going to include with this a side that we don't know. Let's say that we include side C. Well, this would be opposite, and this would be the hypotenuse. So if I'm going to set up a trig equation with one unknown and two knowns, then we're going to recognize that opposite over hypotenuse would be sine for angle B. So sine of angle B would be side B divided by side C. We're going to fill in our knowns. So we have sine of 45.0893 degrees is equal to side B, so that would be 56.853 divided by side C. That's the side I don't know. Okay, now we can solve for C. We can multiply both sides by C. And then, once we multiply both sides by C, then we can divide both sides by sine to get C by itself. So now what we have is C is equal to 56.853 divided by sine 45.0893 degrees. And all we have to do is put that into our calculator. 56.853 divided by sine 45.0893. And I get 80.27726 and so on. And since our side is rounded to the nearest 3 decimal places, we'll do the same thing for side C. We will round to the nearest 3. So 80.277 centimeters. Now we know two sides. And now we can find the third side by using our Pythagorean theorem. So we have a squared plus b squared is equal to c squared. We don't know side A yet, so we'll leave that as a squared. Our b squared, our b is 56.853. Equals c squared, and we just solved for c, and we wrote it as 80.277, and we will square that. And of course we can let our calculator do this work for us. I'm going to subtract 56.853 squared from both sides. So I get a squared is equal to, I'm just going to type this directly into my calculator. And I get that a squared is equal to 3,212.13312. And of course, to solve for a, I need to take the square root of both sides. And we're going to let our calculator do that for us. And I get that a is equal to 56.6756, and we're going to round to the nearest 3 decimal places again. And that would round up to 56.676 centimeters. For the rest of this section, we will be looking at word problems that deal with angles of depression and angles of elevation. The angles of elevation and depression are formed with the horizontal. So if you were standing right here, you establish your initial side of your angle by looking straight ahead. So this will be our horizontal. The angle of elevation is always formed with the horizontal as our initial side, and then looking up from that, sometimes this is called the line of sight. But it's formed with the horizontal, also looking straight ahead and then looking up from there. We would call this the angle of elevation. We can also have an angle of depression. So that means if I'm standing, let's say I'm standing on top of a building and we look straight ahead, we establish first of all this is our initial side. And then if I look down, we could call this the line of sight. This would be called the angle of depression. The angle of elevation and depression are always formed with the horizontal and then looking up or looking down. Here in example 4, we're going to solve our first problem dealing with the angle of elevation. And we have the angle of elevation from a point on the ground. So here we have our point on the ground. Let's say this is our ground. The angle of elevation from a point on the ground that is 15.5 meters from the base of a tree to the top of the tree is 60.4 degrees. So essentially what we're saying is that I have a tree here and my horizontal is the point. If I was standing right here and I was looking straight ahead, that would be my horizontal. And the angle of elevation means I'm going to start there and I'm going to look up and I'm going to look to the top of our tree. This would be called our angle of elevation, and it is 60.4 degrees. So what we want to know is what is the height of our tree, and since we don't know that, we'll call that x, and we have this right triangle that we have formed. And it says that the point on the ground is 15.5 meters from the base of the tree, so we also have that information. So we have a right triangle. We know one angle, we know one side, and we want to solve for x. So we know the adjacent side to the angle, and we want to find the opposite side. So adjacent over, or opposite over adjacent, that would be tangent. Tangent of 60.4 degrees would be equal to the opposite side divided by the adjacent side. And we're going to set up a trig equation using our two knowns and one unknown. So use your right triangle definitions of your trig functions to form a trig equation with one unknown and two knowns. And we're going to solve this for x. We're going to multiply both sides by 15.5, and this cancels, and we end up with 15.5 times tangent of 60.4 degrees is equal to x. And we're going to go ahead and put that into our calculator, and we're going to solve to the nearest tenth. So I get x is equal to 27.3 meters. And make sure that you can put that into your calculator and make sure that that is the answer that you get. In example 5, we are asked to actually find the angle of depression if we are standing at the top of a 97-foot tall building, and we want to find the angle of depression from the top of the building to the base of the building across the street. And we are told that that building across the street is located 42 feet away. So we're going to draw a picture here. Here's our building. And it says from the top, so we're going to pretend like we're standing at the top here. And the first thing that I want to do with an angle of depression or elevation is to first establish my horizontal. So going straight across from the top of the building, here is our horizontal. So we want to establish that first. And then it says the angle of depression from that horizontal, or looking down from there, is what I'm actually going to be looking for. This is my angle of depression. We'll call that angle D. And we are looking down to the base of a building that is across the street. A couple of things. The building that we are standing on is 97 feet tall. And of course, if I look over here, that would mark off 97 feet from the horizontal to the base of the building. We're basically forming a rectangle here. And we're also told that the building is 42 feet away. So we have 42 feet here, as well as 42 feet across the top of our horizontal. So the building, from building to building, 42 feet. And we have our little rectangle here that we can use to help us solve. And we have basically formed two right triangles. So we want to solve for D, and we know two sides of this right triangle. So we want to solve for D. And I know the opposite side and I know the adjacent side. So once again, it looks like we're setting up tangent. Tangent of angle D is equal to 97 divided by 42. So the opposite divided by the adjacent. Now I would like to solve for the angle. And we remember that if I want to solve for the angle, then I'm going to have to use my inverse function. So we're going to type into our calculator tangent inverse. We're going to feed it the function value, and it will spit out for us the angle. We're going to go ahead and round to the nearest whole degree. So I get D is equal to 66.6 degrees, but I'm going to go ahead and round to the nearest whole degree. So we're going to say that the angle of depression is 67 degrees. In our last example, we are given a diagram, and we are told that from a window that is 29 feet above the street, the angle of elevation to the top of the building across the street is 46 degrees, and the angle of depression to the base of the building across the street is 16 degrees. We are asked to find the height of the building across the street. So first of all, let's form our perspective. Here is our window, and it's 29 feet above the ground. When I look out my window straight across, this would be what we would call the horizontal. So we're thinking about from the perspective of this window, here we are marked off and given the horizontal. Now we are told that this window is 29 feet above the ground. So from the ground to that horizontal, this would be 29 feet. And we are told that from the perspective of this window, if I look up to the top of the building across the street, that this would be 46 degrees. This is our angle of elevation. And from the perspective of the window, if I look down to the base of the building across the street, that would be what we call our angle of depression. We want to find the height of the building. Well, we have two triangles basically formed, two right triangles. So here's my right angle for the bottom triangle. Here's my right angle for the top triangle. In the bottom triangle, I know two things. I know the angle of depression, and I know actually the right angle, and then I know a side. I know a length of the side. In order for me to find the height of the building across the street, we're going to have to work with both triangles, because what I ultimately want to know is what is the measure from the horizontal to the top of the building. Let's call that a y value. Let's call that y. So in order for me to solve for that, well, in that top triangle, I only know one angle, and I don't know any sides at all. And in order for me to set up a trig equation, I can only have one unknown. That would force me to have several unknowns, at least two at a time, and so I'm not going to be able to solve for y directly. We're going to have to form some sort of link from these triangles, and what we would like to do is find the length of the horizontal. Let's find this measure of this side of our triangles, the side that they share. Let's find the measure of that. Let's call that side x. So looking at our bottom triangle here, we have our angle 16 degrees, and from the perspective of that angle, I know the side that is opposite of it, and I know the side that's adjacent to it. So we're going to set up a trig equation. Tangent of 16 degrees is equal to the opposite side, so that would be 29, divided by the adjacent, which we don't know, we'll call that x. And now we're going to solve for x. I'm going to multiply both sides by x and divide both sides by tangent of 16. So we get x is equal to 29 divided by tangent of 16 degrees. We're just going to put that into our calculator. And I get 101.135. And let's round to the nearest 2 decimal places here as we go forward. So we'll say this is 101.14. So the horizontal here, the measure of that horizontal, we solve for x there. Now we know that the measure of that horizontal is 101.14. Now for my top triangle, I actually know the angle and I know a side, and now I can solve for that one unknown side of y. Okay, so from the perspective now of our 46-degree angle working within that top triangle, we know also again the side that's adjacent and the side that is opposite. So the y would be opposite, so we're going to do tangent of 46 degrees is equal to y opposite divided by adjacent, which would be 101.14. And of course we are going to multiply both sides by 101.14, and we're going to put this into our calculator and let our calculator tell us what the y value has to be. And I get a y value of 104.73. I'm going to round to the nearest tenth. So now I know that the top part of our building, from the horizontal all the way to the top, would be 104.73 feet. Now what is the height of the entire building across the street? Of course, the height of the building would have to be from the base of the building to the horizontal, so 29, plus from the horizontal to the top of the building, which we found to be 104.73 feet. And when I add those two together, I get 133.728. And we'll go ahead and round. Let's round to the nearest tenth again. So that would make this 133.73 feet. So the height of that building total would be 133.73 feet.